Yo, sorry I am quite late, but I'm here.
Rowdy.
Let's see, I'm just trying to open the docs. Okay. Don't really have much of a agenda set today. Anyone have anything that they would like to talk about?
Hi, Manabu. It's Rishabh here from Red Hat.
Hey,
Hi. So if you remember, I opened up the PR regarding the namespace for that Spark app for the manifest files,
all right,
one
for
of
the
the YAML
customize,
file.
yeah? Yeah,
Yeah. So
yeah,
I
it's
just
being,
wanted to,
go ahead, sorry.
yeah. So I just wanted to make sure if you're okay with reviewing that again. I gave some comments in the thread on in the
Yeah,
Slack thread.
yeah, I've been meaning to
Okay,
reply to
so
you.
my
Like,
whole argument was like this. So in future, okay, we want our the whole we need to have two deployment criterias. One, the Helm charts that we already have, and the other one that we are trying is the customized one. And in future, we want to make sure that they are in parallel. And right now, Helm chart also they are also using the placeholder for the namespace. So that's why I don't want to omit it. I just want to make it parallel to the help charts, whatever is there.
I
And
see.
using the namespace as system is the you can say the default,
Yeah,
whatever.
maybe you could share what do you mean by the this context, I guess. So, because there are others who may not be familiar with the situation. I just want to make sure
Okay.
like everyone is on board. So let me share my screen. Let's see, share. This guy. You can see my screen, yeah?
Yeah, yeah,
Okay, cool. Yeah. So do you wanna kind of walk us through what's happening?
yeah. If you go to the file changes. So I have just replaced the namespace with the system. So in basically Spark operator, we have two things: the operator and the Spark jobs. Okay, so basically, whenever we every other namespace scoped resources in the repo, like in the config, they already have this uh, namespace as system. There are other files in the configs, the manager, the webhook, the other RBAC files, the cert managers, the default also. So they are already using namespace as system. So I just wanted to make sure that this file is also in accordance with them. This is the first case. If you go to the configs, yeah, in configs you can go to the manager. Da, 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 da. Where is the mouse?
Hey, sorry. Where's it again?
If you in configs, if you go to the cert manager,
Set manager.
yeah, choose any of the customization.yaml file. Yeah. Here also, if you see the namespace, that is
Active.
system.
I see.
Okay. Similarly, there are more folders. In any of the folder, if you'll go, you'll find the namespace as system. Even if we check, I'll point a reference to you. Let me give. This is a Kubernetes fix. Here also the main. You can chat. These are like two references that I found where it's a, you can say, let me paste one more. Yeah. So if you even see these two references that I have given here also in the Kubernetes science also 6 also they are using namespace as system, and it also has one more use. So let's like it is very important for the fail fast mechanism. So as we know that we have like two ways to deploy the customize manifest, right? The first one is to the customize. So let's suppose somebody came here and they started reading the customization.yaml file, okay, and they apply the namespace and they output the YAML file. So what they will do, they'll directly go and type customize build config.default because that default is our the main entry point, right? So here, what will happen? Customize will everything take namespace as the system, and it will replace it with the other placeholder. Let's suppose we are using as namespace as a Spark operator. So this value will never be reached in the cluster. And if let's suppose instead of system we have default here, and somebody tries to write it as default already is a particular value somewhere, so it will never fail. But the developer won't be able to catch the like where it is failing.
Okay.
Yeah. So I think that's why I wanted to have system here instead of default.
I guess like my question is, at least like from what I've seen, you typically have like namespace information in the customized files themselves. Is that not the case? Somewhere, right? Customization file. Um, I always thought that was the case. Maybe I'm not right.
For if you're asking about the manager ones.
Um, so like when you have the customization file, you can
Mhm.
have like namespace specified in there. So like for example, you could have a namespace here, if I remember right, and then that would apply the files with namespace, support, and then propagate all that namespace into the. That was my understanding.
Mm.
Does that make sense? Or am I? So like, let's see,
So
customize namespace. Um, let's see. Yeah, something like this essentially.
okay, you're saying that we can always rename it or use it according to our uh, whatever our task is.
So if you have this in, say like if this was namespace system,
Yeah. Hmm.
and then we check this in to the,
Hmm.
customization here, it
Hmm.
should default to the whatever system namespace we defined here instead of just hard coding in the
Okay,
you know what I mean?
that's what I'm saying. Like, let's suppose in our production system, instead of we are using some name ABC. Okay, this namespace is just a placeholder. So whenever we will run it in our production system, it should replace with ABC, right? But default, that particular word default is a recognized keyword in the whole Kubernetes thing. So it will not fail. It will recognize it as a like uh, like it recognizes it some kind of namespace there. It does not fails. So it is not catching it is not catching the fail fast mechanism here. That's what I'm saying.
Is
I
it
see.
okay
So
if I add something over here?
Yes, please.
I think Rishabh, the pull request what you have raised earlier, it is related to the application RBAC, not the Spark operator RBAC, right? I mean,
Yeah.
okay, there are two RBACs in Spark
Yes, yes.
Spark as a whole, right? And
Mm-hmm.
this right now, whatever we are looking at this PR, this is Spark operator applications RBAC, meaning this will be used by the driver.
Yeah, yeah.
And this
Understand.
will be deployed not only in default namespace, but in any of the application wherever you are deploying your Spark application,
Yes.
right? Now,
Yeah.
I shared another link in the chat. Now, why they have used namespace as a default over here is because in the default value in the values.yaml of Helm, line number 452, it is by default, it will be when you install Spark operator on any of the Kubernetes cluster, by default, it will be just looking for the Spark application only in the default namespace. That's the reason
Mm.
why in the Spark, in that particular Spark application RBAC, they have hard coded it as a default. But that's true that it need not to be always default. You can we can use a placeholder over there. And if I'm not wrong as well, when I install the Spark operator, by default that application RBAC won't be installed on the cluster. You need to explicitly install it later part of time as per your needs where you are deploying your Spark application. So let's say in our company, we have deployed our Spark application across 5 different namespaces. And across all these 5 different namespaces, this Spark application RBAC needs to be installed in those particular namespaces. And we have also updated our Helm chart, the default values.yaml. Instead of watching just the default namespace, we have updated it to watch all those 5 namespaces.
Okay.
So that's I think maybe we are getting confused with the Spark operators RBAC versus Spark applications RBAC. Now the PR whatever you have raised is for the Spark application RBAC, which is used by the driver to provision the executor pods in the application namespace.
No, no, I'm not getting confused. I know that we have there are like two things, okay? The first one is operator himself, and the
Mm-hmm.
second one is the Spark driver pod. Okay. So what is happening like in the Go code, uh, can you go to this file in the internals, internals controller controller.go
Mm-hmm.
uh, controller.go. Yeah, here around line number 100 and line 111. Yeah. So wherever we have this queue builder RBAC file, mm, let me around, yeah, around this line queue builder. So this whole the comment section. So whenever we run the make manifest files, okay, so there is controller dot underscore gen. So it read these markers and it produces all the cluster role, right, which is for the whole cluster, and it cannot produce all the service accounts and all the namespace based things. And then second, we have the Spark pods that we are talking about our applications that each company has their own. Okay. So whenever the operator creates a, we can say Spark application, then it launches a driver pod, if I'm not wrong. Yes. Yeah.
Correct. That's correct.
Right. And
And
the
Spark driver
driver,
pod will use the RBAC, the pull request what you have raised. The Spark
yes,
driver pod will use that RBAC to provision the executor pods.
yes,
So in the pull request what you raised, if the default is not a standard, then the system the one you want to replace with system namespace, even that is also not correct. It should be always the application specific namespace, if I'm not wrong. I mean, that's what we did and it's working for us. We always, instead of going with the default, as I thought they have used the default in the initial phase, because in the example that
Okay.
link I shared, they always watch the default namespace in the example.
Okay, let's suppose someone came and they are applying every single file directly. Okay, like they do like kubectl apply minus f all the config file, and
Hmm?
this particular Spark application.yaml file they do. Okay,
Mm-hmm.
so here what kubectl will do, it will read this file literally, and
Yeah.
whatever namespace is written in that file, and that will that we will use, and no transformation will happen. So
Yes, correct.
if this says namespace system, kubectl will try to create the resource in namespace, sorry, system namespace. And
Yes.
if it says default, kubectl will create it in default. So that scenario is where the placeholder matters, right?
Yeah,
So
true.
yeah, right. So but if we have default, it will always succeed silently in the wrong place, because default is already a particular word in Kubernetes. I don't remember that. That's why it will now. Let's suppose we have to write a namespace ABC. It will not able to detect it. That's what I'm saying.
Now, if you replace it with system, how would it detect it?
No, no, yeah. That whenever we write it as system, it will not detect it. So this is how it will fail fast.
Okay, you
It
would.
it will tell us that it is in the wrong place.
I got it, but still, can you? I sent a pull request, a link in the chat. Can you open that link in the chat once?
Mm, yeah,
Go to line number 452. Yeah, line number
yeah.
452. 451. What does it say is which namespaces that Spark operator need to watch for the Spark application or scheduled Spark applications, so that it can create the driver pods in that particular namespaces. And the default value is default namespace. Line number 452, that's what it says. Meaning the Spark application RBAC should already exist in the default namespace. That's
Mm,
the reason
okay,
why in the first case in the Spark application RBAC, whatever the PR you raised, the value is default over there. Now let's say if I remove the 457, 452 line completely, and that's what it says. Um, line where install if a line 488 line. If empty string is included, all name 488. If 4 sorry 448 sorry 448. If empty 448, if empty string is included, all namespaces are allowed. In
okay,
this case, your RBAC should be available in all the namespaces, not just system or default. So maybe I would see this more as we can add more details in the README about this as a note, making sure it's
mhm,
easier for understanding. But I think the example, whatever it is in the repository with the RBAC application RBAC, as per me, I think it's good already.
okay, okay. Thank you.
Please correct
Yeah.
me if I'm going wrong somewhere, Manabu.
Yeah. No. No. I think that makes sense. Because we do look for default. In Helm chart, anyways. And I have been looking at like other repositories on like what they do. Like for example, here's like Flags manifests, and they don't really have namespace defined a lot of things. And I know like Flex is huge into like customize, and I'm pretty sure they know, how to do these things. And my understanding has always been that you probably shouldn't include namespace unless It's somewhat very specific to what you need. So, setting it default is probably okay in my opinion. Instead of just trying to make it to system. And if there are actually, namespaces that are using system in our customized manifest, then that probably needs to be fixed instead of trying to use the system namespace.
I think your original comment about removing the namespace entirely feels right, and maybe just documenting if you need to build some of these resources in a specific namespace, here's how to do that.
Yeah, that's probably a better idea. So when you're using customize, you're supposed to specify a namespace, right? I hope I hope I'm right here. Does anyone like in the um, customize experts?
Yeah, true. But as it's a namespace default is hard coded, the default will take more precedence. It will not get overridden. Like Ali said, I agree that maybe if we can remove that
Yeah,
namespace field completely, that would solve our issue.
yeah, I agree. I think we should just remove it. That way we can full control over the what gets created in what namespace. Does that make sense?
Yeah.
Okay. So there might be other places within the customized folder that might need to be replaced as well if they're like name system specifically. In that case, we probably should update that as well. But yeah, thanks for the contribution. Really, I really appreciate trying to make the customize a better experience because I know it's been definitely in a rougher space than the used to be. Okay, let's see. Anything else you guys want to talk about? Oh, actually, I do have one thing. If you guys are interested in, let's see, the benchmark results. So we have been running a lot of benchmarks using the Apache Carbon. So Carbon is a Spark shuffle service, a remote shuffle service that is, in normal situations, you would have the executors serving as the, shuffle data server as well as doing the compute. So I think I have a architecture here. So, when you have, this is a default way of doing things. So you have, Spark drivers and you have Spark executors like this. The executors would compute some amount of the data and then you'd store it into local disk somewhere. And then other executors may need access to that the data that's stored in another executor. So in that case, the executor has to serve data from this, its own volume and then give it to the other executor. And this can be quite a lot of overhead. And especially if you lose one of these nodes, then you have a lot of problem, right? Because that means Spark now has to recalculate the shuffle data that was originally stored here, but now it's gone. So especially for like a large jobs, like if your job gets like petabytes, then it becomes a huge bottleneck. Because once you lose that shuffle data, you're spending a lot more compute to re-get that shuffle data again. So this is where the remote shuffling service comes into play, right? So you have the Apache Carbon. Um, that's one of the emerging ones, I'd say. And with having a centralized place to serve the shuffle data, it actually gives you better performance and more durability when you are trying to have more dynamic way of using executors. So if you have like a dynamic resource allocation where drivers can dynamically adjust the number of executors. If you don't have remote shuffling service, it's very difficult for a driver to, adjust the number of executors because these executors might be holding this shuffle data, but it's not doing any compute, but it just holds that data. Therefore, it cannot be, removed from the pool of executors. So that's why Carbon is a nice solution when you're dealing with like a large amount of data. And we've done the perform the benchmarks in the past. So these are all based on the 3 terabytes of TPCDS data store. We actually done the 10 terabytes of data recently, and this is the new bit here. And we actually saw a performance improvement. So if you look at the 3 terabytes results, we actually saw a regression in overall performance. But if you use 10 terabytes, you actually see improvements here. So, if you're, if you have large enough data set you're working with, it probably makes sense to use this and you get the, durable or more durable storage. But yeah, if you guys want to, take a look at the 10 terabytes results, it's all here. And yeah, we have some analysis and everything. So yeah, just wanted to mention this. Any questions on this I can answer while I'm still here?
Uh, Hi, this is Venkatesh Verlu from Salesforce. I have
Mhm.
one query related to Caliban. Uh,
Yeah,
I know that I have a similar kind of POC for Salesforce payloads.
yeah.
Um, one query is, do you see any kind of maintenance headache? I mean, yet we need to maintain Caliban as a service. And now the other challenge is Caliban itself. At least I did this POC around a year back. Caliban itself is not horizontally scalable solution at that time. I'm not sure if something changed now. Given that if there is a huge spike at a particular time, then Caliban itself can becoming a hurdle, a bottleneck that you can't scale, and the executors will be waiting for its turn to grab some space on Caliban, the some storage. Do you see any such kind of scenarios, and what was the observations?
Yes, I actually agree that it adds a lot of operational overhead, especially Carbon doesn't have native way of auto scaling itself. There is some proposal out there that try and help with that, but it has not been implemented yet. So we actually did a whole bunch of experiment like over the past week, and here are the best practices what we came up with, and um, one thing that we noticed is that it it has the decommission API, which allows the master to decommission a certain workers, meaning that the workers will not take any new requests for slot allocation, but it's going to keep using or keep serving the existing requests or the existing shuffle data. So that way you can kind of scale your workers that way, but it's definitely not as smooth or as you know I guess it's really not a great solution because that means you can only restart one node at a time or one pod at a time in Kubernetes. Because even with replication enabled, you still have to make sure that you are not restarting two nodes at the same time. Because Carbon only supports replicating to two places, and that is only at push time. It never maintains the two replicas at the same time, or there's no guarantee that you have two replicas at all times. So I agree, and I don't think things have changed that much compared to when you did your research. And I've seen your proposal to do you just essentially are doing it within the actual executors, right? You just make code changes in Spark and then push the data to S3 or wherever you want.
Gotcha. Yeah.
Yeah. So yeah, there's definitely overhead when you're using Carbon, but we did a whole bunch of experimentation here. So yeah, I am actually looking for feedback on this. So if you guys want to take a look and give us some information, I would appreciate it. I'll just put it in the in the doc. Okay. Any other questions on this I can answer?
One quick question. Also at Datadog we had like a small POC for like using Caliborn, but for us, like the limiting factor, like you noticed, like you said in your article, like I noticed this also in your article that for us the limiting factor was cost to S3, like networking costs, IO. And so like we were considering using like HDDs or using like other storage solutions, but like is it a matter of scale that makes like the IO like become manageable, like costs, or what do you think is like the how'd you handle like IO costs to S3?
To S3 specifically?
And I mean in your article you seem to post to S3. So how'd you prevent like the networking costs from like eating any savings that you could get from like the savings?
Oh, interesting. So, before I get to your question, we actually tried doing S3, and the performance regression was quite bad. I'm talking about 16x regression in um, performance. Um, at that point, uh, I couldn't really recommend using it. So it's kind of yeah. Maybe I was doing something wrong. But I would love to know how you guys are doing it. As for the I/O and EBS or the actual storage inputs, it's you know it's difficult to measure that, especially because of the variation in what kind of jobs are you running, right? Um, so there's a company that we talked to. They are using Caliburn in the in production, and they are essentially scaling down the clusters based on time, so that they know when a lot of the jobs are going to be running and when they are not needing it, and they're measuring the I/O requirements and all that just by monitoring, and then kind of trying to come up with the best time to do that. So, we do have some information on like the disk usage and everything here, but you know, I don't know if you're running it in AWS, but the EBS volume, throughputs and IOPS can add up. So, if you are wanting to use EBS, you kind of have to tune it yourself. But there is another solution that if your shuffle data is not as big, you can actually use the ephemeral storage. Let's see, maybe I have it here somewhere. But like if you look at the you know instance type that ends with D, that comes with ephemeral storage that we can use, and it's free essentially. You don't really have you know um, the cost associated with the storage itself. It just essentially comes with the instance, and it actually gives you a lot of much higher throughputs and the IOPS as well, because it's actually physically attached to the node itself instead of having EBS, which is more abstracted away, right? So if you're okay with the risk of the ephemeral storage going away at some point, it's okay to use that. But really, it's really up to you. We actually wrote all about that here. So if you want to, take a look, and then kind of tell us what you think.
Just to be clear, you're just using ephemeral storage on like the actual like Spark executors.
Yep.
Okay. And okay, and it's interesting that you also ran to the same conclusion where like S3 immediately becomes like undoable and then you like have yes.
Yeah, EBS is definitely the recommended solution right now. Um, I've even looked at using S3 Express one zone. The support is not there. I'm probably going to be opening PRs to fix that, but and honestly, I don't know how much time I have for the next couple months. But yeah, at least right now, I do not recommend using S3. Use EBS if you can.
Okay. And I mean it's my first time being seeing these articles, so if I have any more questions, I'll like I can always follow up.
Yeah, feel free to ping me on Slack, and I'll be more than happy to answer any questions.
Cool. Thank you.
Yeah.
One question: is there any a specific Slack group? I just joined this meeting now. I mean, I wasn't
yeah,
there.
we have been just using the Spark Unique Kubernetes Slack channel. How do I copy the link? There. So it's this guy right here. If you have the Cloud Native Slack account, you should be able to join and see everything there. It's a public Slack channel, so you don't have to request joining or anything. And I think we talked about Carbon on, Data Fusion Comet, the Velox and all that. And essentially everything related to, Spark, we talk about that in the channel. So yeah.
Yeah, thank you.
Right. Any other questions before we call it? Right, awesome. Thank you everyone for joining, and we'll see you in a couple of weeks.
Sorry, I mean, if we have time, I just want to touch up 2 points. What we are
Sure.
working on Spark operator. Point one is about metrics. What we have in Spark operator for now, there is a metric that start latency metric.
Mhm.
That, if I remember, that is actually been adding the timestamp when the driver pod marked as running. So
Yep.
that's a start latency. But inside Salesforce, we wanted a more precise metric, which is to represent the operator performance. So what I mean is, when it is about driver pod running state, it relies on a lot of other things, that is Kubernetes scheduler performance and resource availability. If it is, maybe if we integrate with unicorn like that, then the queue capacity and availability, overall resource availability, Kubernetes scheduler now. But we wanted to have a metric which is really represents how fastly that operator is picking these customer or our Spark application. So that's where we thought of maybe having another metric, that is to log when the application is marked as submitted. Do we already have in latest versions, or but we are working on that metric.
Let's see, I thought I published some information around that. Oh, maybe I didn't. But yeah, I don't know what you're talking about. The pot start latency, all that, right? If I'm right, it's fairly basic. I don't think there's anything that you described. So if you have, if you want to add more metrics like that, then I'm all for it. Oh, this is very unfortunate. Actually, I thought I added way more metrics here. Hmm. Okay. Yeah. Yeah, but that sounds like a good PR to me. So please open on PR and I'll take a look.
Yeah, sure. Maybe next time I'll create a pair.
Yeah.
The other one, what we are working on is, I think we all know about this problem, but just want to give the glimpse what we are working on. So we are using Spark Submit CLI as a sub process in the operator.
Hmm.
But Salesforce payloads, it is becoming a bottleneck, because if you go with a limited set of CPU and cores at a time, the Spark operator could able to process only some certain set of Spark applications, due to that Spark submit itself spinning up JVM multiple times, twice I think. So we thought of avoiding that. I think our peers must be connected about this earlier. If you remember,
Ganga, right?
Ganga, yeah,
Yep.
yeah. For that, we deployed. We developed a OSO. We call it as a kind of optimized version of operator for submission, that we written in Golang, and we realized that later points we realized that we are writing almost same resource manager stuff, which is developed in Spark, kind of to build the driver pod and creating all those things. Then we took a different approach now. Instead of reinventing the wheel in Go, how about write a Java service, maybe a REST service, and then use the Spark libraries, and use Spark libraries, which are actually creating the driver part, and then deploy that. Let's suppose submit a service, deploy that submit a service as part of controller container. So now two containers, one is controller container, another one is submitter container. The controller container will do the local host, submitter will directly create the driver part. That way we can eliminate the JVM spin-ups multiple times. So how do you think it sounds? I mean, we did some kind of load testing, something like submitting 1,000, 2,000 applications in a minute with some kind of 2 GB memory and 2 cores. The OSO, I mean, the regular Spark submit CLI is taking to mark everything submitted. It's a kind of 1 hour it is taking. But rather, with this solution, it is able to mark everything into submitted in 3 minutes. It's a huge difference, what I feel.
Yeah, yeah. I think so. The first implementation we did was to have a plugin that runs within the Spark operator itself, if I remember right. And that was just written in Go. Just there's that Golang plugin implementation, right? And from what I heard, that worked. But what I suggested afterwards was to use like some sort of gRPC or REST API, like you said, essentially, so that you can have different services and you can scale, right, between these, just that submitter service.
Yep.
I think there is a open PR that was opened, and I did review it, but I don't think it got any traction afterwards. Yeah, so this one, this adds the gRPC endpoint and client. And let's see. Yeah, maybe I can just link it so you can read about this. Let's see.
Yeah.
All right, so it's in the chat. But it's kind of something that more stuck in the design. At least from my end, at least. It uses the gRPC as an implementation right now. But it comes with a lot of baggage in that we have to essentially redefine the proto, file here, I think. My God, it's been so long since I worked with. Anyway, so essentially you have to redefine the Spark application struct into the prod path essentially struct. So that it adds a lot of maintenance
Yeah.
overhead. So that's why I was little worried about using gRPC. I think let's see, I committed somewhere. Yeah, this bit. So maybe gRPC is not the way to go. Like you said, maybe REST API might be sufficient enough. But really, the goal that we should be doing is to decouple, right? Decouple the Spark operator itself from the submitter. And I'm 100% all for that. So, if you want to work on that, I'll be more than happy to take a look and make it more scalable.
Sure.
Yeah, because like in our benchmark, even like we did see a lot of the let's see. Yeah, like I think we were able to do like what 1,000 jobs per minute, which really isn't that good, right? So, yeah, sorry, I think you were saying something.
Yep. When you're saying that decoupling, do you mean that having the submitter as a standalone service, like how we have webhook as a service now?
Yep, exactly.
Okay,
Um,
that makes
we,
sense.
we talked about it somewhere here. Or maybe it's not the one. But yeah, you're right. So we'll have a different service that is responsible for submitting the Spark jobs. The underlying implementation can be anything, right? If you want to use Spark Submit, you can do it. If you want to use your own implementation, you can do it. But the goal is to decouple.
Makes sense. Probably maybe I'll work on this. I'll create a PR. Maybe we can discuss then.
Yeah, that'd be great.
Yeah. Yeah.
Okay. Any other questions?
Nothing from my end. Thank you.
Okay, awesome. Well, thank you guys for joining, and we'll see you in a couple of weeks.
Thank you.